Hello everybody and welcome to the Creatrix YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at an academy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we'll support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable EC student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join an academy using the code AnkitESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code AnkitESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code AnkitESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous few videos I have told you about the MOSFET amplifiers and the different configuration of amplifier like common gate, common drain, common source, as well as we have talked about multi-stage amplifiers such as the cascade amplifier. In addition to amplifier, we have also observed the frequency response of the amplifier, in which we have derived the lower and the upper cutoff frequency of the MOSFET frequency response. So in this video, what we will be doing is we will be dealing with problems based on the concepts that we have learned in the last few lectures and see what kind of questions can be framed in the examination. So let us start with the first question. It says a depletion type N channel MOSFET is biased in its linear region as a voltage controlled resistor, assuming threshold voltage minus 0.5 VGS2 VDS5 and W by L is 100, COX 10 to the power minus 8, mu n 800. We need to find the resistance of the voltage controlled resistor. Okay. See, we know that in linear region, what is the drain current? Mu n COX W by L into VGS minus VT into VDS minus VDS square by 2. If you want to find the conductance between drain and source, what you will do? Del ID by del VDS. If you differentiate it with respect to VDS, what you will get? Minus VDS. Now, usually we ignore the second term VDS square by 2, or we can write it as mu n COX W by L into VGS minus VT. Is it fine? Now, what you have to do now is find the value of the resistance. Resistance is basically 1 by GDS. So 1 divided by, what is the mobility given? 800. Oxide capacitance, remember you have to take in per centimeter square so that this centimeter square gets cancelled. 10 to the power minus 8 into W by L is 100. VGS minus VT will be 2.5. So 1 by 20 into 10 to the power minus 4. That means 500 ohm. So the value of voltage controlled resistor in this case will be 500 ohm. Remember, the circuit will work as a voltage controlled resistor when it is biased in the linear region. Next problem. In the circuit shown, this should be circuit, not current. The channel length modulation is non-zero. Also, the transistor operates in saturation region and has negligible body effect. We need to find the small signal voltage gain. Okay. Now see, this is your NMOS, and this one is your PMOS. Okay. Suppose this voltage is VDD and this is ground. We need to find V0 by Vin, the ratio of these two voltages. All transistors are operating in saturation. Let me name it as M1 and this one as M3. All are operating in saturation means we can use amplifier model, or you can say small signal model. Okay. Let me show you the model. Okay. I'll draw on the next page. You will ground the gate of the transistor M3. See, the gate of this transistor is grounded. This is PMOS actually, okay. Then you will show this voltage, basically VSG. This is gate, this is source. Then in a PMOS, the current always goes from source to drain. So this current will be GM VSG, or you can say GM3, and it will have an output resistance R03. Okay, this is the drain terminal. Are you fine with this explanation? What I have done in case of PMOS, the direction of current source is reversed and the voltage polarity is also reversed. Instead of VGS, I am using VSG. Now let us see the second transistor. In the second transistor, when we are deriving the, basically what we are deriving? When we are deriving the AC model. In that AC model, we have to ground VDD. If you ground VDD, the source of this transistor gets grounded. The source of this transistor gets grounded. So, the gate is also connected to VDD. It will also be ground. So, for the second transistor again, the gate terminal will be grounded. But it is NMOS. So, the voltage that I will show is VGS. Then I will show a current source GM VGS, or I will write GM2. Okay. In parallel to this, I will show R02. This is gate terminal, this is source terminal, this is drain. Now see that the gate and the drain are connected together. The gate and the drain are connected together. So this is shorting between gate and drain. Is it fine? What about the source terminal? The source is connected to the drain of the PMOS. So this terminal is connected to the source. And this is your V0. Let us see the third transistor. It is a NMOS kind of transistor with gate connected with Vin. This is your Vin, this is gate. The source will be grounded. Between gate and drain, we will have a current source GM1 VGS, or you can write like this. Name the voltage also, and it will be in parallel with the resistance R01. Now the source is grounded, but this drain terminal is connected to V0. So this is drain, this is source. So this drain is connected to V0. Okay. Now we have to simplify this circuit. This is a very crude circuit that I have drawn. I have just replaced each transistor by its equivalent circuit. Now we want to know the ratio of V0 and Vin. How you can find that out? Let us see. If you see this VSG3, this is 0. Why? Gate is grounded, the source is also grounded. So this is 0. If this VSG3 becomes 0, this current source also becomes 0. If this current source is 0, it will be open circuited like this. If it is open circuited, then the only thing that remains in the circuit is the output resistance R03. And this output resistance is connected between the source and the ground. See, like this. It is connected between source and the ground. See, in the second transistor, gate and drain both are grounded. That means this R02, this R02 is also connected between ground and the source. So can I say something like this? I can remove this entire circuit and R03 and R02 are connected between the same two terminals, that is the source terminal and ground. So what I can say is, this current source is basically GM2, VGS2, and here I can place one more resistance R03. Now, what I want to know is, now I want to simplify this circuit. Now see, this current source is GM2 VGS2 and this voltage is VGS2. So can you say like this, the current source is equal to GM2 VGS2, or you can say VGS2 over 1 by GM2. See, the voltage across current source is VGS2 and the current is GM2 into VGS2. So I can say that this current source can be modeled as a resistance, and what resistance will it be? It will be 1 by GM2. Now also you can say the current will be same, GM2 VGS2. That means there are three resistances, and where they are connected? They are connected between V0 and the other terminal is connected to ground. So you can show like this, the equivalent resistance is connected between V0 and ground. And what is this resistance? R equivalent. R equivalent is 1 by GM2 parallel R02 parallel R03. Now see this. If I want to find the output voltage, I have to take parallel combination of this. So I can say RL is nothing but R equivalent parallel R01. So I can replace this entire circuit now. I can replace this entire circuit by a single resistance, that is RL, and this is V0. Now see, this current will be going like this. So V0 will be negative. V0 will be minus GM1 VGS1 into RL. What about Vin? If you see the input side, Vin is same as VGS1. So the voltage gain V0 by Vin is minus GM1 into RL. Okay. So what I can say is, the voltage gain in this question will be minus GM1 into RL. RL was R01 in parallel with R equivalent, which is 1 by GM2 parallel R02 parallel R03. So that will be the voltage gain of this amplifier. Okay. So what I have done actually is, I have done nothing but replaced each transistor by its small signal model and then just simplified the network to find the voltage gain. The next problem. In the circuit shown in the figure, transistor M1 is in saturation and has transconductance 0.01 Siemens. Ignoring internal parasitic capacitance and neglecting the channel length modulation, we need to find the small signal input pole frequency. Okay. Also one more thing, if I go back to previous question, there also it has said one thing. Channel length modulation is non-zero. Why it has said this channel length modulation is non-zero? I told you in saturation we can write drain current as, how we can write? K VGS minus VT square 1 plus lambda VDS. Then I told you the drain resistance or the output resistance is 1 over del ID by del VDS, which comes out to be 1 by lambda ID. If this lambda was 0, then this resistance would be infinite. Are you getting my point? If channel length modulation is 0, the output resistance of the amplifier would be infinite or open circuit. So in this question it wanted to tell us that you can't ignore this output resistance in the small signal model. But here in this question it is saying channel length modulation lambda is 0. That means the output resistance can be ignored. Are you getting my point? If channel length modulation is 0, you can ignore the output resistance. If it is non-zero, you have to consider the output resistance. Now let us draw the small signal model of this amplifier. How will I draw? After the input voltage, there will be a resistance of 5 kilo ohm. This is connected to the gate terminal. Then between gate and source, I will show the voltage VGS. Then between drain and source, I will show a current source GM VGS. Then R0 has to be taken to be infinite. So R0 you will not show. You will ground this VDD. Why we ground this VDD? Because we are doing AC analysis. In that DC sources are grounded. So that means this 1 kilo ohm resistor is connected between drain and ground. Like this. And this source terminal is directly grounded. Like this. Okay. And this capacitor is connected between gate and drain. So this is the capacitor. Now as you can see, this capacitor is connected between input and output. And what it is asking? Small signal input pole frequency. When it is asking the small signal input pole frequency, that means it is asking the input side cutoff frequency. Okay. Input side cutoff frequency if it is asking, then in order to use this capacitance, I have to resolve this capacitance into two capacitances, one at the input side and the other at the output side. And in order to do that, I'll have to use the Miller effect or Miller theorem. So first of all, I will remove this capacitor and find the voltage gain. So I am saying AV is voltage gain in absence of connection between input and output. Now in this case, if I ask you what is V0, you will say that this current will go like this, plus minus will be induced like this, but V0 will have opposite polarity. So you will say V0 is minus GM VGS into 1000. Now we know, since the gate terminal is open circuited, what is the gate current? The gate current is 0. If the gate current is 0, there is no voltage drop in the 5 kilo ohm resistor, or you can say VGS equal to Vin. Now if you take the ratio of V0 and Vin, the voltage gain will become minus GM into 1000. GM is 0.01 into 1000 is minus 10. That is the voltage gain. Now you have to resolve this 50 picofarad capacitor at the input and the output terminal. Okay. So what is the input capacitance? We will say that it is C1 minus AV. 50 picofarad 1 minus 10. That is 550 picofarad. This capacitance will be shown here. That is CMI. Now whenever R and C are connected together, what is the cutoff frequency? 1 by 2 pi RC. In this what will be C? It will be CMI. And what will be the value of R? The value of R will be 5 kilo ohm. 1 by 2 pi into 5000 into 550 into 10 to the power minus 12. So this frequency will come out to be how much? If you put the values, you will get the value of frequency as 57.8 8745 kilohertz. Okay, that is the value of input signal or input pole frequency. Okay, if it has asked the output pole frequency, then what you have to do? You have to find CMO, which is C 1 minus 1 by AV. And in that case, the resistance that you will use will be 1 kilo ohm. Okay. So that is how we can find the cutoff frequency in case of MOSFET amplifier. Next problem, it says two identical, this is actually PMOS transistor, M1 and M2 are connected together as shown below. The circuit is used as an amplifier between the gate and the source terminal, and output is taken between drain and source. V bias and VD are adjusted such that transistors are in saturation. We need to find the transconductance and the output resistance of the combination. See, in the first transistor, the input is connected at gate and output is taken at drain. So what is this configuration? It is common source. In the second transistor, the output of first transistor will work as input. So input is connected at drain and input is connected at source. This is the source terminal. It is working as the input and output is being taken at the drain. That means this configuration is common gate. Is this point clear? By observing the input and output terminal, I can find the configuration of the MOSFET. In the first MOSFET, which is M2, the input is connected at the gate and output is taken at the drain. So it is common source. In the M1, the input is taken at the source and output is taken at the drain. So it is common gate. We know when there are two configuration, common source and common gate, it is a case of cascode amplifier. In cascode amplifier, what did I tell you about the transconductance? The transconductance is equal to transconductance of the first transistor, which is GM2. Okay, the transconductance will be because of M2 where the input is connected. What about the R0? In R0, what did I tell you is, you will take the transconductance of the transistor near the output. Which transistor is near the output? M1. So you will take the transconductance of M1, multiply it by R01 and R02. Okay. So the R0 will be, this option will have to be corrected. This will be GM2 and this will be GM1. So the answer would be C. The transconductance will be because of the transistor at the input, and R0 will take the transconductance of the transistor near the output. If you remember this much in cascode amplifier, you can solve almost every problem. Okay. So what you have to remember in cascode? Transconductance, input transistor you have to take for R0, GM of the output transistor and output resistance of each transistor, that is transconductance of transistor connected to output. Here you have to consider the transistor which is connected to output. Now, next question, in the circuit shown below, we need to determine the voltage gain V0 by Vs. Here we know the value of GM as well as R0. So we don't have to do DC analysis. What I'll do? I'll directly do AC analysis. For AC analysis, what steps do we have to take? Ground, VDD, and we have to short the capacitor. In that case, this 60 kilo ohm and 300 kilo ohm will come in parallel. Okay. So I draw the model. This is Vs. It is connected to 2 kilo ohm resistor. Then this 60 and 300 kilo ohm will come in parallel. 60 parallel 300. Then between gate and source we will show the voltage VGS. Now the source terminal is directly grounded, this one, and between drain and source we show a current source GM VGS. Then this is connected in parallel to the output resistance R0, and this 10 kilo ohm is connected between drain and ground. This is the drain terminal, gate terminal, source. Between drain and ground we have 10 kilo ohm. Now see this, R0 and 10 kilo ohm are in parallel. So if you find out the load resistance, it is R0 in parallel with 10 kilo ohm. 15 parallel with 10 will be 50 by 6 kilo ohm. So I will replace these two resistances by a single resistance. RL. This current is going like this. So V0 will become minus GMVGS into RL. Now what about VGS? VGS is the voltage across this transistor. 60 parallel 300 will come out to be 50. So it is the voltage across 50 kilo ohm. So I'll write VGS is Vs into 50 by 52. Just I am applying potential division between these two resistances. So if you calculate V0 by Vs, it will be minus Gm RL over 50 by, into 50 by 52. Gm is how much? 1 milliampere per volt means 10 to the power minus 3. RL 50 by 6 into 10 to the power 3 into 50 by 52. This gets cancelled. So how much will this come out to be? It will be minus 8.012. Okay. So that is the value of voltage gain of this common source amplifier. That is minus 8.012. So it is providing a 180 degree phase shift. Like common emitter amplifier, the common source amplifier also provides a 180 degree phase shift. So always remember AV is less than 0 for common source, that is 180 degree phase shift. AV is greater than 0 for common gate and common drain, so it has 0 degree phase shift. So whenever it asks you about the gain of the amplifier, make sure that you substitute the gain with the sign. If it is coming out to be negative, you have to give the answer as negative. Next problem. For the circuit shown, the transistor parameters are VTH is given, Kn is given, lambda is given, and IDQ is also given. What we need to find is the transconductance and R0 and VGS, and we also want to find out the voltage not given gain. So we will go step by step. So in an amplifier problem, the first step logically should be DC analysis. In DC analysis, what we will do is, we will open circuit the capacitor and we will short AC voltage source. AC voltage source will be short circuited. That means we are applying the voltage VGG at the gate. Now let me draw the circuit. Okay, this is the circuit. VGG 10 volt 10 kilo ohm. This voltage is VGS. So you can directly say that VGS is equal to VGG, and if the transistor is in saturation, you can say IDQ is Kn VGS minus VT whole square. This IDQ is given as 0.4 milliampere. Kn is given as 0.5 milliampere. VGS we want to find out. VT is 2 volt. So it will be 0.8 equal to VGS minus 2 whole square. So that means VGS will become 2 plus under root 0.8. So it will come out to be 2.89 volt. So the first part is sorted. VGS is 2.89 volt. Now what we want to find out is transconductance and R naught. Now transconductance is nothing but del ID by del VGS. That means del by del VGS Kn. In saturation the current is this much. So it will be 2 Kn VGS minus VT. Now this Kn was 0.5 but it was in milliampere into VGS 2.89 minus 2. So it will be 0.89 milliampere per volt. What about R naught? It is del ID by del VDS, 1 upon del ID by del VDS. Now if you see, it has asked us to ignore the channel length modulation. Okay, because lambda is given as 0. So it came out to be 1 by lambda ID. So it is infinite. So R naught is infinity. So we have found out the second two parameters. Now what we need is the voltage gain. And in order to find the voltage gain, we have to first draw the small signal model. So let me try and draw the small signal model. For small signal model, we will short circuit the DC source like this. So Vi, the input voltage, will be connected at the gate. And between gate and source, I will show the voltage VGS. The source was directly connected to ground. Between drain and source, we will have a current source GM. VGS. R naught is taken as infinity, so we will not consider R naught. But see this resistance, this is drain, source, gate. This 10 kilo ohm resistance is connected between drain and ground. So I will connect the 10 kilo ohm resistor like this between drain and ground. This is V naught. Now by KVL, I can say that Vi is VGS. And this GM VGS current is flowing like this. So I can say that V naught is minus GM VGS into 10,000. Okay. So if you take V naught by Vi is minus GM 0.89 into 10 to the power minus 3 into 10 to the power 4. So that will be minus 8.9. So that will be the gain of the amplifier, minus 8.9. Again it is a common source amplifier, so the gain is coming out to be negative. Next problem. Consider the common source amplifier. The transistor parameters are VTH equal to 1.5. The transconductance parameter is given Kn. Lambda is also given. We need to find the small signal voltage gain and the input and output resistance. Now in the amplifier analysis, the first part is always DC analysis. In DC analysis, we always open circuit the capacitor and short circuit AC voltage source. Okay, so this capacitor will be removed. Now the current here is 0 ampere, which means these two resistances are in series. If they are in series, I can find out the gate voltage just by potential division. 10 into 29.1 by 29.1 plus 70.9. 2.91 volt. Now see, the source voltage is 0. So VGS is VG minus VS. Since source voltage is 0, it will be 2.91 volt. Okay. So now we have the gate to source voltage. What I can do is, I can find out the drain current. Okay. Or I can find out the transconductance. In saturation, the transconductance is del ID by del VGS, which comes out to be 2 Kn VGS minus VT. So 2 into 0.5 into 2.91 minus 1.5. So that is 1.41 milliampere per volt. Remember the units. Kn is given in milliampere, so the transconductance will also come in milliampere. Okay, is it fine? Now the next thing is lambda is given, so R naught you can find out like 1 by lambda ID, but for that I need the value of ID. ID will be how much? ID will be Kn VGS minus VT square. So if I go on the next slide, ID will be Kn 0.5, Vg minus VGS minus VT is 2.91 minus 1.5 square. So this current will come out to be approximately 1 milliampere. So what about R naught? 1 by lambda, that is 0.01. Lambda is given as 0.01 into ID. ID is 1 milliampere. So you can say 100 kilo. That is the value of R naught. Now what I need is the small signal voltage gain. For that I have to perform AC analysis. For AC analysis, what I will do is, I will short the capacitor. Okay. And short DC source. Is it fine? So in this circuit, if we short the DC source like this and we short the capacitor, then these two resistances come in parallel, 70.9 and 29.1. So how I will draw? First I will draw Vs. It is connected in series with 4 kilo ohm resistor. Then 70.9 and 79.1 and 20.9, sorry, 70.9 and 29.1 will come in parallel. I will write it as R1 parallel R2. Between gate and source I will show a voltage VGS. Between drain and source there will be a current source GM VGS. Source was directly connected to ground. This current source is in parallel with a resistance R naught, and see this last resistance 5 kilo ohm. It is connected between drain and ground. So that is 5 kilo ohm. That is V naught. So now if you want to find the output resistance, you will see from here R out. This R out is simply R naught in parallel with 5 kilo ohm. That is 100 kilo ohm will be connected in parallel with 5 kilo ohm. So it will come out to be 4.76 kilo ohm. What about input resistance? In input we don't consider the source resistance. Input resistance will be simply R1 parallel R2, that is 70.9 in parallel with 29.1. So it comes out to be 20.63 kilo ohm. Now if you want to find out VGS, you have to do potential division between these two resistances. Vs into input resistance by input resistance plus 4. And what about V naught? You have replaced these two resistances in parallel by a single resistance, which is R out. this current is going like this, so plus minus will be like this. V0 is opposite, so we will say V0 is minus Gm VGS into R out. Take the ratio of or substitute the value of VGS. You will get V0 by Vs is minus Gm R out multiplied by Rn over Rn plus 4. If you substitute the values, what will you get? You will get the value as minus 5.9. So that is the voltage gain of this amplifier. Okay. So that is the complete analysis of amplifier that we have to do when we are dealing with MOSFET amplifier. First DC analysis, then find the parameters, then form the small signal model. Next problem. Consider the following source follower circuit. We are given the transistor parameter VTH, Kn, lambda. We need to find transconductance, voltage gain and output resistance. Again, to find the transconductance, we will first perform DC analysis. In DC analysis, we have to open circuit the capacitor. So this will be removed. We know that the input current, input gate current to MOSFET is 0 ampere. So these two resistances will be in series. If they are in series and I apply voltage division, I can say VG is equal to 12 into 463 by 463 plus 162. Okay, that is the value of VG. So now this VG will come out to be, how much will it come out to be? 8.8896. That will be the value of VG. Once I know the value of VG, what I can do is, I can say that this current is ID. This current will also be ID. This value is VGS. So I can apply KVL. The voltage at this node is VG. If I apply KVL, I'll say VG minus VGS minus ID into 0.75 equal to 0. So VGS is VG minus ID into 0.75. That is the value of VGS. Now I know that I can also write ID as K VGS minus VT square. You can ignore the channel length modulation and only consider channel length modulation when you are finding the output resistance. Okay. Other than that, you can always ignore the small signal. Always ignore the channel length modulation. That means ID will be 4 milliampere per volt square into VGS 8.8896 minus 0.75 ID minus VT is how much? 1.5. This will lead to a quadratic equation in ID and you will get two values of ID. If you solve this quadratic equation, first one will be 12.179 milliampere and the second one will be 7.97. Based on this, we can calculate the value of VDS. Okay. How you will calculate the value of VDS? The drain voltage is 12 volt. What is the source voltage? 0.75 into ID. So VDS is 12 minus 0.75 ID. For both the values of current, you can calculate VDS. If ID is taken as 7.97, it will come out to be how much? 6.02. If you take it to be 12.179, into 0.75, check how much will this come out to be? 12 minus 12.179, then 0.75 you can write as 3 by 4. Okay. If you want to solve in fraction, it will come out to be 2.86. What about VGS? VGS was coming out to be how much? 8.8896 minus ID into 0.75. So VGS here will be, in the first case, 8.8896 minus ID into 0.75. Okay. So 2.9121. What about second case? 8.8896 minus 12.179 into 0.75 minus 0.244 less than VT. So this case is not possible. So we have to choose the first value 7.97. Okay, because otherwise the transistor will not be on. Now once we know the value of ID, I can find out the value of GM. GM is how much? It is del ID by del VGS. So it is 2Kn VGS minus VT. In saturation we are finding. Kn was given as how much? Kn was given as 4. VGS 2.9121. VT. VT is given as 1.5. Okay. So it will be 8 into 1.4121. 11.2968. But remember, Kn is in milliampere per volt. So it is milliampere per volt. What about R naught? It is 1 by lambda ID. Lambda is given as how much? 0.01. ID is 7.97. Okay. So 100 divided by 7.97 into 1000. So 12.547 kilo ohm. Okay. So that will be the value of R naught. Once we have the small signal parameters, what we can do is we can find out the value of the voltage gain. So how to find the value of voltage gain? We will have to draw the small signal model. Okay. So when you draw the small signal model, what you have to see? You will short circuit the capacitor and you will ground this VDD. Okay. If you ground this 12 volt, this 162 and 463 will come in parallel. So I'll draw VS. It will be in series with 4 kilo ohm. Then there will be a resistance R1 parallel R2. Then between gate and source, I will show the voltage VGS. Between drain and source, I will show a current source GM VGS. And now the source is connected to a resistance which is 0.75. This terminal gives the voltage V0. Then in parallel to this voltage source GM VGS, we have R0. And this terminal is drain. Now see, this drain terminal is directly connected to ground. So this drain gets connected to ground. Okay, that is the small signal model. Now, what you have to observe is, what is the value of first of all R1 parallel R2. R1 parallel R2 is, what is R1 and R2? 162 and 463. 162 in parallel with 463. Calculate how much will it come out to be. 162 into 463 divided by the sum of both, that is 162 plus 463. So it is 120 kilo ohm. So if I find out this voltage V is Vs into 120 by 120 plus 4. So Vs into 120 by 124. That is just I have applied the voltage division. Now see this resistance R0. This terminal of 0.75 and R0 is common. The other terminal is connected to ground. That means R0 can be drawn in parallel to this, and we can remove R0 from here. Which means this V0 is GM VGS, that is the current going into the resistor. R0 parallel 0.75. Since R0 is very high, R0 parallel 0.75 is almost 0.75, or you can also calculate it exactly. If you calculate it exactly, it will come out to be 0.72. Now we know the value of V0. You can apply KVL like this. V is VGS plus V0. V0 is GM VGS into 0.72. 1 plus GM into 0.72. We know the value of V. So VGS 1 plus GM 0.72 is 720 ohm is equal to Vs into 120 by 124. So you can say Vs is VGS 1 plus GM into 720 whole divided by 120 over 124. Now we know the value of Vs, we know the value of V0. What I can do? I can find out the value of voltage gain. The value of voltage gain is V0 by Vs. So it will come out to be, VGS will get cancelled, GM into 720 by 1 plus GM into 720 into V0 by Vs we are taking. So it will be 120 by 124. So this voltage gain will be approximately equal to 0.86. Okay. So as you can see, this value is positive. It is providing 0 degree phase shift, and for source follower the voltage gain is always less than 1. Now we need to find the output resistance. The last part it was asking us the output resistance. So if you want to find out the output resistance, what you will have to do is, you will have to first make the value of Vs 0. So output resistance is V0 by I0 when Vs is 0. So if you make this Vs equal to 0, then V also becomes 0. We need to find V0 by I0. Now this V was equal to, by KVL, VGS plus V0. It is 0. So V0 or VGS is minus V0. That means this current source is how much? It is minus GM V0. So if you apply KCL here, I can say I0 plus minus GM V0 plus is equal to, incoming current is equal to the outgoing current. So I0 is GM V0 plus V0 by R0 plus V0 by 0.75. So you can say that V0 by I0 is how much? 1 over GM plus 1 by R0 plus 1 by 0.75. So this will come out to be how much? 74.8 ohm. That is the value of output resistance. So output resistance is always V0 by I0 when Vs is 0. Okay. So this kind of problems can be asked in the exam based on MOSFET amplifier. I can ask you about the parameters such as input resistance, output resistance and the voltage gain. So this is all from this lecture, and I hope you can now solve the problem based on single stage and multi-stage amplifier. Thank you.
So for 12 months, the pricing is 3250, but if you apply the code Ankit ESC, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250 with code Ankit ESC, it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution and to give GATE and ESC at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESC. And other than that, my friends, you can download the Unacademy Learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/GateAIR1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JEE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these 2 channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESC. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.